You may have seen the headlines, the forum posts, the urgent video clips. An object is supposedly on a collision course with Earth, set to arrive in November of 2025. It's a terrifying thought. A story perfectly crafted to spread through the digital ether, packaged with grainy images and cryptic predictions. It feels immediate and it feels real. But behind the alarm, a more fundamental question arises. Is it true? And in an age of rampant misinformation, how would we even know? To answer this, we must embark on a calm, scientific journey. We will begin by exploring the sophisticated systems humanity has built to separate fact from fiction in the night sky. From there, we will delve into the history of our planet's real and dramatic encounters with cosmic visitors and examine the incredible steps we are now taking to protect ourselves. Finally, we will venture into the truly strange, the verified real-life mysteries, from interstellar messengers to unidentified objects in our own atmosphere, that serve as a profound reminder of just how much we still have to discover. The global watchtowers, eyes on the cosmos. Contrary to the impression given by online rumors, humanity is not blind to the dangers of space. The truth is, there are eyes on the sky, operating constantly from every corner of the globe. They belong to a dedicated public and international collaboration of astronomers and scientists who form our planetary defense system. At its heart is NASA's Planetary Defense Coordination Office, whose mission is unambiguous: to find, track, and characterize near-Earth objects, NEOs. They are, in essence, our cosmic lifeguards on duty. This global network utilizes powerful survey telescopes such as the Pan-STARRS in Hawaii and the Catalina Sky Survey in Arizona to methodically scan the heavens night after night. These instruments take sequential pictures of the same patch of sky, allowing powerful computers to compare the images and search for anything that moves. A star or a distant galaxy will remain fixed, but an asteroid, following its own orbital path, will betray its presence as a tiny, shifting point of light. Once a potential NEO is spotted, its coordinates are sent to the Minor Planet Center, a global clearinghouse that catalogs and distributes this data. This allows astronomers worldwide to point their own telescopes at the object, gathering more data points. Each new observation, each new measurement of its position, helps to refine the object's orbital trajectory with astonishing precision. What begins as a wide, uncertain cone of probability is gradually narrowed until its path through the solar system can be predicted with confidence. This wealth of data feeds into a sophisticated system at NASA's Jet Propulsion Laboratory known as Sentry. This automated collision monitoring system maintains a catalog of every known near-Earth object that warrants our attention and continuously calculates its path for the next 100 years, checking for any potential intersection with Earth's own orbit. This brings us back to the rumor of a 2025 impact. If a celestial body of any significant size were on a collision course with Earth for next year, its existence would not be a secret confined to a fringe internet forum. It would be the single biggest, most verified news story on the planet. Every astronomer, both amateur and professional, would be able to observe it and independently confirm its trajectory. The fact that the world's observatories are not sounding this alarm tells us everything we need to know. The watchtowers are quiet, and in the business of planetary defense, silence is golden. But history tells us that the sky has not always been so peaceful. When the sky fell, a history of real impacts. On the morning of June 30th, 1908, the sky ripped open over a remote stretch of Siberian forest near the Podkamennaya Tunguska River. An explosion, now estimated to have been 1,000 times more powerful than the atomic bomb dropped on Hiroshima, unleashed a devastating shock wave that flattened over 2,000 square kilometers of taiga. An estimated 80 million trees were leveled, laid down in a radial pattern like matchsticks, pointing away from a central point. Due to the region's extreme remoteness, the first scientific expeditions did not reach the site for years. When they finally did, they found a scene of utter devastation, but puzzlingly, no impact crater. The scientific consensus today is that a small asteroid or comet, perhaps 50 to 60 meters in diameter, entered the atmosphere at hypersonic speed. The immense pressure and heat caused it to disintegrate in a massive airburst several kilometers above the ground. The object itself never struck the Earth, but its explosive energy did. Had this event occurred over a major metropolis like London or Moscow, the death toll would have been catastrophic. The Tunguska event was a stark wake-up call from the cosmos, a demonstration of the destructive power held by even relatively small celestial objects. For over a century, that wake-up call remained a historical curiosity, a story from a distant time and place. Then, on February 15, 2013, the world witnessed a modern-day encore. This time, dashboard cameras, security systems, and cell phones captured the event live. An asteroid, much smaller than the Tunguska object at only about 20 meters across, entered the atmosphere over the Russian city of Chelyabinsk. It had gone completely undetected. The resulting fireball was momentarily brighter than the sun, leaving a long, smoky trail hanging in the winter sky. The subsequent shock wave, arriving a minute later, shattered windows in thousands of buildings across the city. Over 1,500 people were injured, primarily by flying shards of glass. Chelyabinsk was a visceral reminder that the threat isn't just theoretical or historical. The cosmic shooting gallery is real, and its targets can be unpredictable. The question was no longer if humanity would be threatened, but what we could possibly do about it. Humanity fights back. The DART mission. For the vast majority of human history, our role in the cosmic drama has been that of a passive observer. We could only watch, wonder, and, in the face of a threat, hope. That era is now beginning to end. We are moving from being inhabitants of our world to becoming its active guardians. This transition was powerfully demonstrated by the DART mission, the Double Asteroid Redirection Test. The concept was straight out of science fiction, yet executed with brilliant scientific precision. Could humanity intentionally crash a spacecraft into an asteroid to alter its course? The mission's target was a binary asteroid system composed of the larger asteroid Didymos and its small moonlet, Dimorphos. Dimorphos, which posed no threat to Earth, was the perfect cosmic bullseye for this unprecedented experiment in planetary defense. On September 26, 2022, after a 10-month journey through deep space, the golf cart-sized DART spacecraft locked onto its target. In its final autonomous moments, its onboard camera transmitted a breathtaking stream of images back to Earth, showing the rocky, alien surface of Dimorphos in ever-increasing detail. The world watched live as the spacecraft hurtled towards its destiny, a silent collision millions of kilometers from home. The impact was a spectacular success, observed by telescopes on Earth and in space, including the Hubble and James Webb Space Telescopes. The collision kicked up a massive plume of rock and dust, a celestial cloud that shone brightly for days. But the crucial question remained: did it work? Did we move it? Scientists answered this by precisely measuring the time it took Dimorphos to orbit its larger companion. Before the impact, that orbit was 11 hours and 55 minutes. The mission team had hoped to shorten it by at least 73 seconds, with an optimistic goal of around 10 minutes. The final result was astounding. The impact had shortened the orbit by 32 minutes, proving the kinetic impactor technique to be a far more effective method of asteroid deflection than even the most hopeful models had predicted. DART was a monumental proof of concept, humanity's first successful step in learning how to defend our home planet. The interstellar messenger, the mystery of Oumuamua. As our ability to observe the cosmos grows more powerful, we are finding that not all visitors are so straightforward. In October 2017, the Pan-STARRS telescope spotted something truly unprecedented. It was an object, but its trajectory was a sharp hyperbola, indicating it was moving far too fast to be gravitationally bound to our sun. This was not a member of our solar system. It was our first confirmed visitor from interstellar space. It was given the name Oumuamua, a Hawaiian word meaning a messenger from afar arriving first. And from the moment it was discovered, it was deeply weird. First, there was its shape. By observing the periodic dimming and brightening of the object as it tumbled through space, astronomers deduced that it must have a bizarre, highly elongated shape, perhaps 10 times longer than it was wide. No known asteroid or comet in our solar system looks anything like it. Then there was its motion. As Oumuamua looped around the sun and began its journey back out into the void, it accelerated. It was being pushed by some force other than the sun's gravity. For comets, this behavior is common. As they are warmed by the sun, their ice turns to gas in a process called outgassing, which acts like a series of tiny rocket engines. But when astronomers pointed our most powerful telescopes at Oumuamua, they could find no evidence of a cometary tail or a gaseous coma. It was accelerating without any visible exhaust. This scientific puzzle has led to a fascinating debate. Most astronomers are working to find a natural explanation. Perhaps Oumuamua was a nitrogen iceberg, a fragment chipped off a Pluto-like exoplanet, and its outgassing nitrogen was simply invisible to our telescopes. Others have proposed it was a rare type of hydrogen iceberg. A few, however, most notably Professor Avi Loeb of Harvard University, have proposed a more radical, extraordinary hypothesis. The object's extreme shape, its lack of a visible tail, and its anomalous acceleration are all, he argues, consistent with it being an artifact of an extraterrestrial technology. Perhaps a solar sail, a thin, reflective craft designed to be pushed by the pressure of starlight itself. While this remains a highly speculative claim, the enduring mystery of Oumuamua serves as a powerful reminder that the universe can send us objects that fundamentally challenge our assumptions. The UAP question, from science fiction to national security. Sometimes, the most puzzling objects aren't distant visitors from other stars, but unidentified phenomena right here in our own backyard. For decades, the topic of UFOs was largely relegated to the realm of folklore and science fiction. In recent years, however, something significant has changed. The conversation has shifted from UFOs to UAPs, unidentified anomalous phenomena, and the people discussing them are no longer just civilian enthusiasts, but fighter pilots, intelligence officers, and NASA scientists. Declassified reports and credible testimony from military personnel describe objects that perform maneuvers seemingly beyond our current technological capabilities. These UAPs are reported to exhibit extreme acceleration, achieve hypersonic speeds without any visible means of propulsion or aerodynamic control surfaces, and demonstrate an apparent ability to move seamlessly between the air and the sea. In 2022, recognizing the potential threat to aviation safety and national security, NASA commissioned an independent study panel to approach the UAP issue from a purely scientific perspective. Their conclusion, released in 2023, was twofold. First, they stated clearly that there is no evidence to suggest these objects are extraterrestrial in origin. Second, and just as importantly, they concluded that the phenomena are real, and that the single greatest obstacle to understanding them is a severe lack of high-quality, systematic data. This is the core of the scientific challenge. The data we currently possess is often fleeting and anecdotal, collected by military sensors designed for tracking conventional aircraft, not for rigorous scientific analysis. To a scientist, a blurry infrared video or even a compelling eyewitness account is not enough. What is needed is a multi-sensor approach, collecting synchronized and calibrated data from different instruments on a single event. The goal of these official inquiries is not to chase aliens, but to solve a data problem. Are these phenomena secret drones from another nation? Are they some form of unknown atmospheric or plasma event? Or are they something else entirely? At present, we simply don't know. And for a scientist, the words, "we don't know," are not an admission of failure. They are an invitation to investigate. Conclusion: the great silence. From debunking internet rumors to tracking real asteroid threats, from developing planetary defenses to investigating interstellar mysteries and puzzling phenomena in our own skies, one common thread unites all these endeavors: the search for answers. This search ultimately leads us to one of the most profound and humbling questions we can ask, a puzzle known as the Fermi paradox. Our galaxy contains hundreds of billions of stars, and modern astronomy has shown us that planets are ubiquitous. Statistically, many of these stars should host Earth-like planets in their habitable zones. If even a tiny fraction of those worlds developed intelligent life, and a fraction of those developed interstellar travel or communication, the galaxy should be teeming with signals and activity. And yet, when we point our instruments to the sky, we are met with a great cosmic silence. Perhaps that silence tells us that intelligent life is incredibly rare, a precious accident in a lonely cosmos. Or perhaps we are simply not yet listening in the right way, our technology too primitive to detect the true nature of the galactic conversation. Or maybe, as the case of Oumuamua suggests, the messengers that pass through our neighborhood are simply too strange for us to immediately comprehend. Whether it is an asteroid we must learn to deflect, an interstellar rock that defies easy explanation, or an anomalous blip on a pilot's radar, the universe constantly reminds us that there is so much more to learn. The key is to continue our exploration, not with fear or credulity, but with the essential tools of science, with rigor, with skepticism, and with a deep and abiding sense of wonder.